Algebra I, 13.3a, Quadratic Equations and Completing the Square. Now, if you haven't seen Squaring Binomials video from 13.2b, I really wish you'd watch that one first. There's a link in this video's description so you can just click on it really quick, all right? I don't want you to get lost or confused because of something we spoke about before and you weren't here, all right? So knowing how to use completing the square, it's going to help us write quadratic equations in standard form. It's also going to help us find the vertex of our parabola. And it'll tell us if our parabola opens to the side, up, or down. It's also going to help us next year in Algebra II or in analytical geometry and calculus. A quadratic equation in the form of x plus h squared equals d, it can be solved by finding the square roots of both sides of the equation. We can write a quadratic equation in this form, and we can also solve it as we have with others before. So x plus 3 squared is the same thing as x plus 3 times x plus 3, right? We can FOIL this. It's going to equal x squared plus 2 times 3x, which is 6x, right? Plus 9. We can find this really quick and complete this square. When we see this, all we have to do is cut this 6 in half, divide it in half to the 3, and we square the 3, and then that's the third term. See? So check this out. We can change an expression like x squared plus 10x to a trinomial square. We can change it so that we've got the plus c at the back end of it and complete the square. We take half of x's coefficient, not this one, where it's got 1x. We take half of its coefficient, so 10 divided by 2 is a 5. We square it to 5 times 5, which is 25, and we add it onto the back. Isn't that easy? That is so easy. You take this middle x coefficient, you cut it in half, you square it, and add it to the back. And this trinomial is the square of x plus 5. Now, the one thing you've got to be careful of is that this new expression after completing the square is not equivalent to the original expression. We had x squared plus 10x, didn't we? So what if x equaled 2? And we plugged a 2 in wherever x was. So we had x squared plus 10x. That would be 2 to the second power. That would be 2 times 2, which is 4. Plus 10x would be 10 times 2. That would be 20, right? So on this side, we'd have 24. But look at our trinomial, x squared plus 10x plus 25. Let's plug 2 in for x. 2 times 2 is 4. 10 times 2 is 20. But we have our plus 25 here, see? And that would be 49. So don't make the mistake thinking that they're equivalent before and after we did the completing the square, okay? They're two completely different, all right? So check this out. We can complete this square. X squared minus 5x. We take half of the x coefficient, and because it's a 5 and it's a weird number, it's odd, we just leave it as 5 halves, okay? We square it, so 5 halves times 5 halves, well, that gives us 25 over 4, doesn't it? We add that to the back of our binomial, and we now have a trinomial. This trinomial is the square of x minus 5 halves, see? And again, it's this expression after completing the square is not equivalent to the original one up here. It's completely different because now we've got this c value, this 25 fourths. If we let x equal 3, that would be 3 times 3 is 9, minus 5 times 3 is 15. That would be a negative 6. But on this side, if we plug in 3 for x, we get a 9 minus 15, but then we have to add this 6 1/4. When we simplify 25 fourths, it comes out to 6 1/4. So after we have our minus 6 on this side, we still have to add 6 1/4, so we have a positive 1/4. So see how that third term completely changed its value? All right? So our next video, 13.3b, we're going to talk about how to solve quadratic equations by completing the square. And of course, if you want to go to any of the previous videos from Chapter 13 and some from Chapter 12, the links are going to be in this description, okay? So you can just click on them really quick. So that's how you take a binomial and turn it into a trinomial, all right? You complete the square, all right? Bye.